All right, so we're on to chapter 3, which is solving equations and problems. And so we're finally going to actually be solving, for once, algebra problems. You probably already know how to do some of these from pre-algebra, but now we're officially learning it in here. So here we go. So 3-1, transforming equations and addition and subtraction, okay? So the addition property of equality states that if A, B, and C are real numbers and A equals B, then A plus C equals B plus C, and C plus A equals C plus B. So basically it's saying that if you add C to both sides, it's going to stay the same if A and B are already equal. So it doesn't change the problem. Now we have the subtraction property. Property of equality, very similar. If A, B, and C are real numbers and A equals B, then A minus C equals B minus C. So as long as you subtract the same number from both sides, if A and B are already equal, then it stays the same. This is kind of saying these two properties allow equations to be changed yet stay equal. So as long as we do the same thing to both sides, we're not changing the problem. Okay. Now, the goal while solving an equation is to solve for the variable. So we get the variable by itself. So it'll be like solve for x or solve for whatever it is, whatever variable it happens to be. So our example 1, we have x minus 6 equals 13. We want x by itself, so as long as we do the same thing to both sides, it will stay equal. And what we need to do is we kind of need to get rid of this negative 6, the subtracting 6. So we have to do the opposite, which would be adding 6. So if we add 6 to one side of the equal sign, we have to add 6 to the other side of the equal sign. So these 6's cancel out, so we're left with x on the left side of the equal sign, and then we have 13 plus 6, which is 19 on the right, so x equals 19. Now, 5 plus x equals 27. Well, this is technically a plus 5 right there, right? Because it's positive. So we have to do the opposite, which would be subtracting. So we have to subtract 5 from this side to get x by itself. But if we have to subtract on one side, we have to subtract on the other side to keep them equal. So those cancel out, and we're left with x equals 22. Now, we have negative x minus 2 equals 16. So first I'm going to add 2 because I want the numbers to be together. Since I'm doing the opposite of subtracting 2, I'm adding 2, but what I do to one side I have to do to the other. So those kind of cancel out, and then we get negative x equals 18. Now this is not our answer because x has to be by itself. It still has a negative in front of it, and that's not, x can be a negative number, but we cannot have a negative in front of the variable. Now, some of you might know how to do it using division or multiplication, but we haven't gotten there yet, so we can only use addition right now. So what I'm going to do is I'm going to actually add x to both sides, okay? And that gives us 0 on the left and x plus 18 on the right, and then I'm going to subtract 18. So I basically flip-flopped them. So negative 18 equals x, which we know by the symmetric property that x equals negative 18 because it doesn't matter which side we have it on. So there we go. So that's what we're doing now until the next video notes you'll learn multiplication and division. So keep that in mind. Oh, now for number 5, example 5. So we need to distribute this negative because I can't combine inside here, so I need to distribute the negative first. So I'm going to be distributing that first. So I have negative 6, a negative y, which would be plus y, a negative times 2 would be negative 2 equals 14. I'm going to combine like terms so I don't have to move around so many things. So I'm going to combine negative 6 a negative 2, which gives me a negative 8, plus y equals 14. Now I need y by itself. Now that I've distributed and combined, I'm going to add 8 to both sides to get y by itself. So y equals, and that would be 22. There we go. Now a word problem. Now, for these word problems, what you're going to need to do is you're going to need to set up an equation and then solve. Okay, so I know you might be able to do it without an equation, but I want you to do an equation. So there you go. So it says Cora ran 400-meter dash in 56.8 seconds. This was 1.3 seconds less than her previous time. What was her previous time? Well, I'm going to say x equals her previous time. So if I know x is her previous time, and then I needed to subtract 1.3 because we know that 56.8 is 1.3 seconds less than her original time, or her previous time. So therefore, we know, you probably could have done this in your head, that you're going to need to add 1.3 to each side, but we're now able to show it because we have our equation. So we now get x equals, and that's going to be 58.1 seconds was her previous time. And we can double check that by saying, we know that 56.8 is 1.3 less. So we would say 58.1 minus 1.3 equals 56.8. So there we have it. So make sure you set up an equation. All right.